Welcome to EDU World Space.
Alright guys, we're doing chapter 18, problem 70 of Chemistry Central Science. So it was estimated that the eruption of Mount Pinatubo volcano resulted in the injection of 20 million metric tons of SO2 into the atmosphere. Most of this SO2 underwent oxidation to SO3, which reacts with atmospheric water to form aerosol. Write for the chemical equations for the process leading to the formation of aerosol. So you're going to have F SO2 plus O2 yields 2 SO3. Then SO3 will further react with water, to form H2SO4. So B, the aerosols caused a 0.5 to 0.6 degrees Celsius drop in the surface temperature in the northern hemisphere. What is the mechanism by which this occurs? So aerosols have specific effects on how the temperature of, aerosols have very specific effects on how the temperature of your atmosphere works. And or rather, the temperature that is experienced by the planet is dependent on the molecules in the atmosphere, and these molecules have different effects on how they interact with light. So most aerosols actually reflect sunlight. So you can think of, let's say your planet is right here, and here are rays of sun coming and hitting it. It's normally they would hit the surface of your planet. Part of what warms the planet is the fact that sunlight is hitting the surface, and that warms up your planet. However, aerosol can actually reflect light back away from the Earth. So not as much light can reach the surface, and this causes a scenario where you have a change in temperature. Like after volcanic eruptions, there's so many particles in the atmosphere that light just physically cannot get to the surface of the planet and warm it up. You can think of it almost like it's shielding the planet's surface from the light. So let's go to part C. The sulfate aerosols, as they're called, also cause a lot of ozone from the stratosphere. How might this occur? So when sulfuric acid is in the atmosphere, they condense into aerosols. So nitrogen oxides react with the surface of aerosols to form nitric acid. Normally, as these nitrogen oxides react with ozone depleting chloride or ClO to form less ozone depleting substances. However, because the sulfuric acid removes those nitrogen oxides, the ozone layer becomes more sensitive to chlorine and ClO. In this case, ozone concentration decreases. So you can think of nitrogen oxides as basically acting as a check on ozone depletion, because they basically play interference for ozone depleting compounds so that the ozone layer doesn't get destroyed. However, sulfuric acid, this will get rid of some nitrogen oxides which are necessary to protect the ozone layer. There. So that's what causes the loss of ozone from the stratosphere.